Hello children, we are going to discuss certain problems in electrochemistry which are going to be faced by you in NEET or JEE mains examinations and also other state competitive examinations. So here the question is, which one of the following material conduct electricity? Which one of the following material conduct electricity? Options are diamond, barium sulfate, crystalline sodium chloride, fused potassium chloride. So here they are asking which substance will conduct electricity. The substance can conduct electricity if he has either free electrons or free ions. Free electrons are available in metals and also in non-metals. Graphite is also having free electrons. And ionic compounds in their fused state or in aqueous solutions, they have free ions. So if any one of these options satisfy either free electrons or free ions, it can conduct electricity. Now let us see options. Diamond. Diamond is an allotrope of carbon in which 4 valency electrons of carbon are involved in bonding. So no free electrons are available in diamond. So diamond cannot conduct electricity. Then barium sulfate. Barium sulfate is ionic compound but is not in fused state or in aqueous solution, so it is also unable to conduct electricity. Then crystalline sodium chloride. Crystalline sodium chloride is a solid, so this is also unable to conduct electricity. Here the fourth option is fused potassium chloride. Fused potassium chloride means ionic compound KCl in its fused state or in aqueous solutions, it ionizes to give K plus ions and Cl minus ions. So here free ions are available, that's why this is it can conduct electricity. So fused NaCl is the right option. Now next question is, electronic conductor is. Electronic conductor means here they are asking which is an electronic conductor. Electronic conductor is a conductor which can conduct electricity with the help of flow of electrons. Metals conduct electricity through electrons, so metals are considered as metallic conductors or electronic conductors. In non-metals, graphite also have free electrons, so it can also conduct electricity. So either graphite or any metal can be considered as electronic conductor. Now let us see the options. NaCl. NaCl is an ionic compound, so it cannot conduct electricity, so this is wrong. Diamond is also non-conductor because R 4 valencies of electrons are involved in bonding. Silver is a metal, it has free electrons, so it can conduct electricity. KCl is an ionic compound, it is not in fused state or in aqueous solution, so it cannot conduct electricity. So the correct option is silver, that is third option, AG. Which of the following is conductor of electricity? Now they are simply asking which of the following is conductor of electricity. Options are diamond, so it is an insulator, it cannot conduct electricity. Graphite, so We already discussed that graphite has free electrons, so it can conduct electricity. In non-metals, only graphite can conduct electricity. Whereas carborundum means SiC, silicon carbide. So it is a covalent compound, it cannot conduct electricity. Silica, SiO2, this is also a solid covalent compound, it is also unable to conduct electricity. So the correct option is graphite, second option. In metallic conductor, the current is conducted by the flow of what? In metallic, we already discussed that in metals, the conductance of electricity is through electrons. That's why they are called as electronic conductors. So in metals, the conductance of electricity is through electrons. So this is the correct option. Ions, it is not correct because in only ionic compounds, through ions, electricity is conducting, and atoms cannot conduct electricity, molecules also unable to conduct electricity. Conductance of electricity is possible only through free ions or free electrons. Free ions are available in ionic compounds in their fused state or in aqueous solutions. In metals and graphite, free electrons are available. That's why they are called as electronic conductors. In which of the following HCl conduct electricity to large extent? In which of the following HCl can conduct electricity in a large extent? So, the quantity of electricity that conduct in an electrolytic conductor will depend upon number of free ions. So, number of free ions are available when it is in diluted state or in aqueous state or in fused state. So, now let us verify the things one by one. One is liquid HCl, another one is aqueous HCl, third one is HCl in benzene, fourth one is gaseous HCl. So, HCl can conduct electricity when it is in ionic conditions, because if it is ionized as H plus and Cl minus, then only it can conduct electricity, because HCl is a covalent compound. So covalent compounds cannot conduct electricity unless they were ionized. HCl can conduct electricity only when it is ionized. So ionization of HCl is maximum in aqueous solutions, not in liquid solution. HCl also some certain extent, but less number of H plus ions are present. In benzene it is not dissociated. In gaseous HCl also free ions are not available. So in aqueous HCl is completely ionized because it is strong acid and more number of ions are available and more amount of electricity will be conducted. Then solid NaCl is a bad conductor of electricity. Solid NaCl, we already discussed that. Ionic compounds, when they are in solid state, ions are at fixed positions. They cannot move from one place to another place. An ionic compound can conduct electricity only the ions are in free state. Ions are in free state for an ionic compound only in their fused state or in their aqueous solutions. So solid NaCl cannot conduct electricity because it is not having any free ions. Now let us see the options. Solid NaCl is a covalent compound. This is wrong because it is an ionic compound. But solid NaCl has no free ions. Yes, this is correct. solid NaCl is no free electrons. This is also wrong because free electrons are available only in metals. Solid NaCl has migration of ions. No, this is wrong. Migration of ions will take place only when it is in a fused state or in aqueous solution. The decrease in electrical conductivity of metals which increase in temperature due to the increase of. So, in metals, the conductance depend upon temperature. When temperature increases, resistance of the metal increases. Resistance means stopping or retarding the flow of electrons. When temperature increases, flow of electrons, the speed of electrons will decreases. So, increase of temperature increases resistance. Due to the increase of resistance, conductance will decrease because conductance and resistance are opposite in reciprocal of one another. Now, the velocity of electrons, the resistance of metal, the number of electrons, the number of metal atoms. So, the decrease in the electrical conductivity of metals with increase in temperature is due to increase in resistance of the metal. Sodium metal in liquid ammonia is an ionic conductor, an electronic conductor, a mixed conductor, non-conductor. Sodium metal, when it is kept in ammonia, in liquid ammonia, this Na will dissociate or ionize as Na plus and 1 E minus. Because of that ionization, free electrons are available. So, free electrons. Now, these ammonia molecule surround sodium ion and also surround electrons. Because of that, in liquid ammonia, solvated, they are called as solvated sodium ions, solvated electrons. So, solvated sodium atoms, ions and solvated electrons are available in the solution. So, here ions are also conducting electricity. Due to the availability of free electrons, electrons are also conduct electricity. Due to the availability of free solvated ions, ion also conduct electricity. So, sodium in liquid ammonia will be a mixed conductor. But sodium in solid state, in an isolated state, it is an electronic conductor. Sodium in its isolated state, it is electronic conductor because of the availability of free electrons. Whereas in liquid ammonia, sodium releases electrons and it exists as sodium ions and electrons. So, here it will act as ionic conductor. So, hence it can be considered as a mixed conductor. Reason for increasing in electrical conductance of electrolyte with increase of temperature. With increase of temperature in an ionic conductor, increase of temperature increases ionization. Due to the increase of ionization, number of ions in a unit volume will increases. And again, due to the increase of temperature, the velocity of ions also increases. So, with increase of temperature, ionization increases and velocity of electrons also increases. Because of that, in ionic conductors, increase of temperature increases the conductance, whereas in metallic conductors, increase of temperature decreases the conductance. This is the difference between metallic conductor and ionic conductor in the terms of effect of temperature. In metallic conductors, increase of temperature decreases the conductance due to the increase of resistance. In ionic compounds, increase of temperature increases the ionization and velocity of electrons are also increased. These are the two reasons. So, here the options are increase in the number of ions, because when ionization increases, number of electrons or ions are also increases. Increase in the speed of ions, yes, when temperature is increased, kinetic energy is increases, that's velocity is also increases. Increase in the degree of dissociation of electrolyte. So, all three options are correct. So, that is fourth option is correct. Next problem, a solution of sodium metal in liquid ammonia strongly reducing agent due to. Reducing agent means the substance which oxidizes itself, which donate electrons, is said to be a reducing agent. In liquid ammonia, sodium atoms ionizes as sodium ion and electrons. So, electrons are in more free state in liquid ammonia than in sodium in a isolated state. That's why in liquid ammonia, due to the availability of free electrons, it will act as a strong reducing agent. Now, let us see the options. Sodium atoms, sodium hydroxide, sodamide, solvated electrons. So, this is the correct answer, solvated electrons. Choose the wrong statement. Now, here some statements are given. We have to choose the wrong one. The statements are: electrical conductance of an electrolytic conductor increases with increase in temperature. Electrical conductance of an electrolytic conductor increases with increase of temperature. Electrolytic conductor means electrolytic conductor means ionic compounds. In ionic compounds, they ionize to give ions. So, with increase of temperature, the dissociation of ions will increase. When dissociation increases, number of ions are increases, so conductance will increase. So, electrical conductor increases with increase in temperature. So, this is correct statement. Electrical conductance of a metallic conductor increases with increase in temperature. This is wrong. In metallic conductor, increase of temperature decreases the conductance. So, conductor, this is wrong statement. Electrical conductance of a metallic conductor decreases with increase in temperature. Yes, this is correct. Degree of dissociation of an electrolyte increases with dilution. This is also correct. So, the second option is wrong. So, they are asking for choose wrong answer. So, second option is correct. Now, here matching type question was given. So, electronic conductor, list 1 we have electronic conductor, non-electrolyte, electrolytic dissociation, Arrhenius theory. Then aqueous urea solution, solid sodium, electrolytic conductor, radioactivity increases, conductivity rises with temperature. Now electronic conductor. Electronic conductor means it should be a metal or graphite. So here graphite is not there, but metal is there. So sodium is considered as electronic conductor. Non-electrolyte. Non-electrolyte means the substance which will not ionize in aqueous solution. Urea is a non-electrolyte. So for this option 1. Electrolytic dissociation. Electrolytic dissociation means conductivity rises with temperature. Electrolytic dissociation. So this one. Arrhenius theory. According to Arrhenius theory, this one. This was related to electronic conductor. So ionization takes place. So electrolytic conductors were given by Arrhenius theory. So A1, A2, B1, C5, D3, C5, D3, 2, 1, 5, 3, that is third option. Which of the following is 100% ionized at any dilution? So, at infinite dilution, either weak electrolyte or a strong electrolyte will completely ionize. But they are asking at any dilution, that means even at low dilutions also, that is high concentrations also, it has to be completely ionized. According to Arrhenius theory, strong acids, strong bases, aqueous solutions in their fused state or ionic state are completely ionizable. So out of these options, let us verify these conditions. One is CH3COOH. This is a weak acid, so this is wrong. HCN is also a weak acid. This is also wrong. NH4OH is a weak base. This is also wrong. Here we have NaCl. NaCl is a salt. It completely ionizes at any dilution as Na plus and Cl minus. So third option is correct. Now, which of the following with 1 molar concentration conducts more electricity? So the quantity of electricity that conduct by a conductor will depend upon number of available ions. If more number of ions are available, it can conduct more electricity. Which of the following with 1 molar concentration conducts more electricity? So the more conductance is possible if more number of ions are available. More number of ions are available when it is more diluted. So here it should be a strong electrolyte also. Strong electrolyte, it ionizes in a large extent and it will give more number of ions. So here if we observe, sulfuric acid is a strong acid, so it will conduct more electricity. Now let us verify other things also. Boric acid is a weak acid, so it cannot conduct electricity. Phosphoric acid is also weak acid. Acetic acid is also a weak acid. So first option, sulfuric acid, since it is a strong electrolyte, it ionizes in a large extent to give more number of electrons. More number of ions and conduct more electricity. Next question, the degree of dissociation of an electrolyte in aqueous solution depend upon. Degree of dissociation will depend upon temperature and also as concentration and also as nature of the electrolyte. So all the three are correct. It's depend upon temperature, it's depend upon concentration, it's depend upon the nature of electrolyte. So fourth option is correct. Next problem, At infinite dilution, the degree of dissociation of sucrose in aqueous solution is. Sucrose is a non-electrolyte. Sucrose is a non-electrolyte. So, it cannot dissociate at any concentrations. So, its infinite dilution also, the degree of dissociation is 0. What happens at infinite dilution in a given solution? The degree of dissociation is unity for weak electrolyte. What happens at a infinite dilution? At infinite dilution, degree of dissociation will increases. Electrolytes will 100% ionized. All intra-ionic attractions are disappear. So, all the three options are correct, because when infinite dilution, degree of dissociation increases, electrolyte is 100% ionized. When it is 100% ionized in a large quantity, the distance between the ions is more, so there will be no attractive forces. So, all the three are correct. Next, the following are some statements about electrolytic cell. Now, here we have to discuss about electrolytic cell. Electrolytic cell is a cell in which an electrolyte is undergone to chemical reactions that we call it as electrolysis. Here two metal rods are used for electrolysis. They are said to be electrodes. The negative electrode is said to be anode and positive electrode is said to be negative electrode is said to be cathode and positive electrode is said to be anode. When external EMF is applied, these ions will move towards the oppositely charged electrodes. Now, let us see what is there. The following are some statements about electrolytic cell. In this, chemical energy converted into electrical energy. Wrong. Here, electrical energy is utilized to conduct chemical energy. This means electrical energy will be converted into chemical energy. In this cell, electrons flow from cathode to anode. No, electrons are flow from cathode to anode. Cathode is reduced here. That means it takes electrons. So, they are released from anode. So, electrons are flow from anode to cathode, but not cathode to anode. This is also wrong. In this cell, reduction takes place at cathode. Yes, in any cell, reduction will take place at cathode and oxidation will take place at anode. In this, cathode is positive electrode. So, no, cathode is a negative electrode. So, out of these, only option C is correct. Then choose the correct statement regarding the electrolytic cell. It is a device in which chemical energy is converted into electrical energy. This is wrong. Electrical energy will be converted into chemical energy. Anode is shown by negative sign. This is also wrong. Anode is shown by positive sign. Oxidation reaction takes place at anode, as this is correct statement. Electrons flow from cathode to anode. This is also wrong. They flows from anode to cathode through battery. So, option 3 is correct. Then, the products of electrolysis of aqueous NaCl solution are aqueous NaCl. In aqueous NaCl solution, we have NaCl dissociate to give Na plus and Cl minus ions. Aqueous means H2O. When H2O is present, this is also dissociate to give H plus ions and OH minus ions. So, during electrolysis, cations will move towards cathode, there they reduced. Anions will move towards anode, there they oxidize. When two or more ions are present, they selectively displace at cathode. Out of Na plus and H plus ions first displace as H2. 2H plus 2E minus gives H2. So, this is cathode reaction. Then out of Cl minus and OH minus, Cl minus ions will discharge first. 2Cl minus gives Cl2 plus 2E minus. This is oxidation and this is reduction. So at cathode hydrogen gas is liberated and at anode H2 gas is Cl2 gas is liberated. So H2 gas at cathode and Cl2 gas at anode, that is second option is correct.